one final example of being able to work with the Poisson distribution. And again, this one's not too difficult, just a little bit of an extension. The number of potholes in a major highway in Chicago occur at a rate of 3.4 per mile, 3.4 potholes per mile. And suppose the highway administration is repairing a 5-mile stretch of highway. So what are the mean and standard deviation of the pothole in that 5-mile stretch? And then what is the standard deviation? So most people initially looking at this problem might say, okay, well, lambda is going to be predicated upon what we already know. Lambda is going to be 3.4, but that is not correct because that's 3.4 per mile, and we're looking at a 5-mile stretch. So lambda is actually going to be 3.4 times 5, which should work out to be 17, but let's just go through and verify that. So we're going to say 3.4 times 5, and that's indeed going to be 17. All right, so you have to be careful with this so that when you read the instructions to see, okay, well, am I extending that? Now, the square root of lambda is going to be the square root of 17, and I believe that we just figured that out in the previous problem. Square root of 17 is going to be, oh, we didn't figure that out. I think we had to figure out square root of 15, 4.123. All right. So that's your mean and standard deviation. Probability of 16 potholes. All right, so for letter B, probability is 16, given that lambda is 17. Lambda to the x, so 17 to the 16, e to the minus x, or lambda, which is minus 17, divided by 16 fact. Right? So we're just going to plug that in, and in our calculator, that's just going to be lambda, which was 17 raised to the 16th, and then we do our second ln, e to the minus 17, and then we're going to divide that by 16 math, and then factorial. And we get 0.0962. We'll just say 0.096. Right. So about 9.6% probability. All right. Now the last one's a little bit sneakier. What's the probability that there are less than 4 potholes in the 5-mile stretch? All right. So now some of us might set it up like this, P of 4. All right, but that's not the case. We want less than 4. So how do we think about that? Well, there's 4 possible outcomes less than 4. So less than 4, there could either be 0 potholes, or 1 pothole, or 2 potholes, or 3 potholes. So for us, what we're going to do is we're going to find all of these probabilities, and then we're going to add them up. All right, so with these discrete distributions, it's actually very similar to when we went back to the very definition of combinations, when we had to do the less than 2 or more than 3 or something like that. We just have to add all of them up. All right, so this is going to be, now a lot of these are going to be really small, by the way. So just bear with me. So this is going to be 17, or I'm sorry, lambda to the x, so 17 to the 0, e to the minus 17 divided by 0 fact. And what I'm going to do is I'm just going to enter all these in the calculator at once, just because they're all going to be really small. And we should end up with a pretty small number anyway. So 17 squared e to the minus 17 divided by 2 fact. And then finally, 17 cubed e to the minus 17 divided by 3 fact. All right, so in our calculator, so just bear with me in a moment and maybe do this along with me just to make sure I don't make any errors. So 17 raised to the 0, and then e to the minus 17 divided by 0 factorial. All right. And that's going to give us a really small number if we hit enter. So let me show you what happens. If you hit enter, notice it gives us like 0.0000004. All right, because this is really 10 to the minus 8th power. So what we can do instead is let's just add all these up because we get really small numbers. So just bear with me. So 17 raised to the first, e to the minus 17, or e to the minus 17 divided by 1 factorial. And by the way, we know that 1 factorial is 1, but just in case you don't trust me, all right, plus 17 to the second, and then second e to the minus 17 divided by 2 factorial. And we know that 2 factorial is 2, but that's fine. We'll just type it in as 2 fact. Hopefully we're not making any syntax errors. And then finally, for the last one, we're going to say plus 17 to the third, e to the minus 17. And then we're going to divide that by 3 math fact. All right, now it's going to be a pretty small probability. So this is what we end up with, 4.063 times 10 to the minus fifth. All right, so, and make sure you always want to read this. All right, so on occasion students will miss this, and unfortunately if they miss that, they miss out on full credit. So we end up with 4.063 times 10 to the minus 5, or if we just want to write it in standard form, 4 zeros and then 4063. All right. That basically means it can't happen. All right. I mean, it can happen, but it's not going to happen almost. So the probability that there are less than 4 potholes in the 5-mile stretch, if we know that there's an average of 3.4 potholes per mile, it's going to be almost impossible. All right. So keep that in mind when you're computing these sorts of things. Realistically, we're just trying to determine if it's feasible or if it's one of those things that we shouldn't expect to happen.